Hiya. I've had a couple of messages over the weekend just asking about hand pulls and do we need gas regulators. What's Cornie kegs? Can I use it with different types of containers, for example? So I did try and write a reply, but it got really wordy, and I thought anybody reading it is going to lose the will to live very quickly. So I thought I'll just do a quick video and just explain some of the basics. First thing is the gas. So we have either CO2, 100% CO2, or we have a 70-30 mix, which is 70% nitrogen, 30% CO2. The difference between the two gases is CO2 is widely used in like fizzy drinks, for example, so Coca-Cola. If you was to open a bottle of Coca-Cola, leave the lid off, you could probably go back the next day and it would still be relatively fizzy. So that CO2 is quite happy at ambient pressure, which is what we're living. It's quite happy at that to stay in a liquid for a bit longer. Nitrogen, on the other hand, would be off. So that would be as flat as a pancake very quickly. What we need to bear in mind is that the atmosphere that we live in is 79% nitrogen and 21% oxygen. So it's nearly all nitrogen anyway. So CO2 is far better for keeping drinks carbonated. So that's one basic thing that we just need to bear that in mind. The hand pulls, these are great things. As you can see, I've taken the cooling jacket and the insulation jacket off this one. Don't know what you can make out there. There's a cylinder with a piston in there, and as I pull that forward, as I pull a pint, that piston is actually moving up the cylinder. Now what that's doing is it's obviously forcing the beer out with the spout, but it's also sucking fresh beer in from the bottom. As I move that down, there's a valve built into the top of the piston in there, and as I move that down, it allows that beer that's been drawn in to go above the piston, ready for the next cycle. So it's constantly sucking beer in and forcing it out the front. So that's a beer pump or a beer engine. That's where it gets it from, cylinders and pistons and all that. So that's how that works. What we need to do then is look at what container we're going to use to keep our beer in. Great things, bagging box. This is the bag out of one of the boxes. Simple, just a polythene bag with a tap on. We have an adapter tap that fits over the top, and I know a few of you have already got these set up. So that's where we are. So basically that there is a one-way valve in there, and all that allows us to do is suck beer out and nothing to go back. It's as simple as that. The great advantage of a bag is that as we're drawing that off, the bag's collapsing. So we're not sucking air in to replace the vacuum we've created by pulling the beer off. So for that reason, your beer in the bag should last maybe a month or so if it's kept at the right temperatures. Stick it in the fridge when you're not using it. Great things. The only downside with these is that the CO2 will escape. The more you draw it off, you'll sometimes find that when you get these delivered, they've built up a little bit of CO2 in there. It's very important that you stand it tap up when you first use the bagging box. Take the security tag off and just let the valve, just let that excess gas off there. The reason for that is that once we've connected this pump to the connector and to the bag, if there's pressure in the bag, there's nothing in the line from there to where you pour it from the spout to stop that beer from just free flowing through here. The other thing to bear in mind is really the bag wants to be on a level or less with the pump. The minute you start putting the bag higher than the pump, you've got gravity then allowing the beer to run through and conceivably just start free flowing. So it's very important there's no pressure, even if it's only gravity, with the bags to the pumps. So that's important. There is a device, this is more like a demand valve, and sometimes pubs especially would fit these, and all that is until you pull that, there's a diaphragm in there, until you pull and that diaphragm frees the beer from going through. So unless you're actually pulling on the handle and creating a demand, that valve will stay shut. If I'm honest with you, in the homebrew situation, if you're just pulling a few pints from a box, as long as you make sure there's no gas in there and you're disconnecting it, you don't really need one of these. These are great for pubs and maybe multi-pump setups, but yeah, they're available. So yeah, so that's the bag in the box. The other thing traditionally we used was cask. So cask, just a steel container or aluminium, and it has keystone at the top, just a plastic peg, and it has a shive that fits into the front. So we would put the keystone in, fill it with beer, break that down with a hammer, and off she goes to the bar. Thing to remember with these is nothing of this is screwed in, so they're not really pressure vessels. They will take a little bit of pressure, obviously, but they have been known to blow if they're left out where it's warm, especially because it can kick off a fermentation again in there, which will create CO2, and we'll blow one of these out. And believe me, that's it's quite funny to watch if it's not your house it happens in. So yeah, try and avoid that. When these go to the pub, first thing they would do is put that on a rack that's actually spring loaded. So that work goes on, and as long as the weight of the beer is on the spring, it's compressed and it lays flat. As you pull the beer off, the spring actually forces the barrel, the cask, sorry, that way, and it reduces waste. So that's how that one works. The first thing a pub would do when the beer is delivered is use a hard peg, keep the keystone in, use a hard peg, and there's actually a soft piece of plastic in the top, and break hard peg in, and then wiggle it about, trying to keep the pressure on, and just let the excess gas out of there, the excess CO2 that's built up. So they would let that out of there, and then they would put a soft wood peg in, which is porous, so it lets air in. And then they would break a tap into the bottom that just simply connects to the hose, to the hand pump. So basically that's what it is. As they pull the beer off, then that tilts up, and here we go. So you can see even then, it's crucial that you tap, that you peg these barrels, because if you don't, and if you didn't peg it and you just braid your tap in and connected that to the front of the barrel, it would literally just free flow if you didn't have one of these valves on. So it would just free flow out of there. So it's crucial that we don't have any pressure going into there. It's crucial. What we came up with there, what somebody came up with, I wish it was me, but I didn't, is this thing called the cask wedge. And what this does is we actually leave the shive in there, don't peg it, turn that off, there's a little fitting goes in the top there, and you literally braid that through, and then turn your peg to let the gas out. Once you've done that, you can take the top off and you push that through there and just connect it at the top. What that does, that actually floats on the top of the beer, and it draws the beer out from maybe an inch below or 20 mil below the surface of the beer. And as the beer level goes down, obviously that goes down and lays on the bottom. great little invention. Your beer, your hand pull line just goes straight onto the cask wedge connector. It's designed to take 3/8 or ½ inch internal diameter brewery hose. The other thing I want to get onto now is the problem with this is, as you're pulling a pint off, you're sucking air in. Now air, as we know, is 21% oxygen. So that oxygen will react with the surface of the beer and it will oxidise it, send it off, in other words. So generally the life of a cask of beer is tops a week. Within a week it will be going even at cellar temperatures. So what we try and do, or what some Bright Sparks come up with, is there's actually a fitting that fits onto the cask wedge that will connect to a bottle of gas. Now, if you had a bottle of gas, you would need one of these things, a regulator, and you would need to set the reg at virtually nothing, and connect it to this. And then what would happen then is you would pull your beer out of the keg, out of the cask, and instead of sucking air in, it would actually suck in whatever gas you've connected to this, preferably CO2. So instead of sucking the oxygen in, it will suck CO2 in. Generally, theoretically, that should then last as long as the bagging box, probably times in its lifespan by 3 or 4. One issue with that is the regulators. We use a lot of welding regulators and things like that. The issue with them is they are cheaper, and 9 times out of 10 they're okay, but they can tend to creep. So when you set your pressure, they can start to creep the pressure up. If that happens in this scenario, you've got the disaster of all your beer going missing quite quickly. So either invest in a better reg, or there is actually a valve on sale, a cask aspirator valve, and what that is, it's about 3 times the size of one of these, and what it does is, as you pull that off, it will let that little bit of CO2 through, but it won't let it, no matter what pressure you've got on the back of it, it will never let that full amount of pressure through. So it's kind of a safety valve really. They're probably about 40, 50 quid, plus or minus. So they're quite good. And you soon make that money back obviously by having your beer last that much longer. So that's a cask. So Cornies, Cornie kegs. These are actually the syrup containers for again all the soft drinks in the pub, but they're ideal for what we do, and definitely for home bars they're perfect. You can get a chest freezer and just put a temperature sensor on there, and these you can stack as many of these as you can in a chest freezer. These are great for home brew and home bars. And what they have is pressure relief valve. That middle part lifts out. I'll try and do it now. One. There we go. And we've got 2 pillars there. So one's for gas in and the other one is for beer out. They obviously had me in mind when they designed them, because it's G grey for gas and B black for beer. So we've got them 2 fittings on there. Again, exactly the same as this thing that goes into a beer keg. So that is the tin that goes into the top of a beer keg. You would connect your keg coupler, and again you've got beer out, gas in. Once that's down, both them valves are open and you're away. So the beauty of these is you can use a keg on a hand pull, you can use a Cornie keg on the hand pull, you can use a cask on the hand pull, and obviously you can use the bag in the box. The advantage of this and the keg is that if you're not using your beer and you find it going a little bit flat, you can introduce a little bit of CO2 and disconnect it and let that CO2 reabsorb into your beer. You don't want a great deal of pressure on there, maybe just half a bar, and then obviously then before you use it through the hand pull again, you need to release that, you need to vent it. But your beer will have taken some of that CO2 on, and the head will last a lot longer. So I think I've covered what I wanted to say. So basically, just to recap really, the bag in the box, perfectly fine, connected up, just easy. Once you've finished using it, just disconnect it, any beer left in there, put that bag in box back in the fridge, and you're off again. The only downside of it is, if it's kept for any amount of time, the CO2 will naturally come out, and what you'll find is that as you're pulling that, instead of pulling conditioned beer through there, conditioned means it's got a really low level of CO2 in there naturally. Instead of pulling that through, the CO2 has started to go, so you're actually mixing it with air, which again we said is nearly all nitrogen anyway. So you will get a head on your beer, but it won't last as long, so you'll have to just drink it quicker. So that's as simple as that is. Bag in box, if you're going to use them over the weekend, you won't have that issue. It's only when you've had it for like 2-3 weeks, you'll find that the head won't last as long. Just one other thing I wanted to say quickly. I know this has gone on a little bit. The taps. The other way we would use 70-30 mix is in a pub where you've got a long run to your tap. Obviously, you need more pressure. If you was to use CO2, the beer would just become overgassed. So we use a mixed gas to push that already carbonated, not conditioned, but carbonated beer through any length of beer line to the tap. The other thing to bear in mind is this is just your normal beer tap, and you can see on there that's see-through, you can see that it's just a nozzle. What Guinness use, a lot of the nitro taps as they call them, is it's just a really thin disc with little holes in, and that goes on to your tap. Now that is now a nitro tap, and it's a nitro tap because it's going to be pushed through there, because you need that much more pressure. It's going to be pushed through with a nitrogen mix, a 70-30 probably, because you need more pressure to push that through. And again, if you used to use CO2, you would probably end up with just overgassed beer. So I hope that all explains something to where we are. If I haven't got, I can get most of the things that you'll need for your to set up your bar at home. So just send us a message. I'm sorry this has gone on for nearly 20 minutes now, so I'll leave you with that. If you've got any questions at all, just let me know, and if I can't answer them, I'll find out for you. So cheers, thank you. Ta-ra.